Yeah. So yesterday we have covered until joins. Okay. And we'll continue with this set operators. Okay. So before that, I told you, right? You can log into this hacker rank or lead code, and there you can practice your ab initio. Sorry, SQL. Okay. So set operators, basically, this is mathematical set kind of operations where you have different tables. Assume you have table one, table two, table three. Likewise, you have different tables. And assume in your actual projects, right? Suppose assume that you have extracting or you are receiving the data for transactions, maybe for different regions. Okay, so you have to consolidate or accumulate on a every day basis, and you need to make this as a master copy of transactions on that particular day. So for that, what you need to do, you need to get transactions file from different regions. Assume that there are 10 different transactions files. So simply what you can do is you can union those files and make it as into one single file. Okay, so that you can do. Um, so during this, right, during using this set operators, only one thing is you need to have the same columns, same set of columns, same columns in the sense it's not like column names, but if you have in your first table, if you have 5 columns, so in your second table also you should have 5 columns. So likewise, the number of columns and the data type of those columns should be same. So then only that will work on that. So the set operators will work on those kind of tables. Okay, so those you have to remember. So now, um, yeah, if you use union, right? So it will combine all the tables into one single table, not file, single table. Okay. So when you use this union, right? So it will remove the duplicates. It will remove the duplicates. If any duplicate records are there, it will remove the duplicates and create the table. Suppose sometimes I want duplicates as well. Suppose though there are duplicates, I don't want to remove them. I need to allow duplicate records as well. So in that case, there is other operator that is union all. So you will be using union all while combining the data from different tables. Okay, so that is second one, and you'll be having intersect. So intersect is combination. Intersect is common records. So you have table one, table two, and I want only the records which is common in both the tables or all the three tables. Then you can use this intersect operator. Okay, so in those cases, we go with intersect. And third one is minus. The fourth one is minus. Minus is something I have records over here which are not present in table 2. So the records which are present only in table 1 and which are not present in table 2, that you can consider that as minus. Okay. So likewise, you can use these operators, set operators in your SQL. Let me log in to. Okay, so this is simple to practice. Okay, you just give your practice. Um, okay, so on those set operators. Okay. And the next topic would be subquery. So subquery, yesterday we have seen, like we can write a query inside from class or inside where class, or even in select as well. We can be able to write some query and we can substitute that result in that particular where condition or from class. So if you are writing such kind of logic, those kind of queries we can call it as subquery. So there is another concept called correlated subquery that we'll discuss. So subquery we have seen yesterday. And CTE. So this is very common usage of SQL nowadays. Most of the projects we can see this as CTE, common table expression. So concept is simple. So the advantages of CTE is readability. So we'll discuss CTE first and then we'll come back to this part. Okay. CTE is basically it's a temporary table. Okay. So temporary table or temporary variable, you can call whatever you name it, you can consider that temporary table or temporary variable. And the scope of that particular common table expression, what we are writing, so that is only to that particular query. So you can't use that in the other query or in other interface. No, it is just to that particular query alone. Okay, so once the query is done, your CTE, that variable will be gone. Okay, so that is one thing. We'll see how to write the CTE. Suppose you have this. Today we'll continue with SQL. So whoever is already aware of SQL, right? Maybe they may get a little bit of boring, but we need to be on top of it. I think somebody is okay. So okay. Yeah, maybe I'll try to execute one query, sales order detail. Sales order detail and quantity, that is exported. Product wise, total unit price. Total line total. Okay, so assume from this particular table, I want to get based on product, what is the total amount purchased? Okay, so maybe to write that, you can simply write something like product ID and then sum of line total. Okay, and then what you need to do, you need to group by product ID. So based on product ID, I want to get that particular total. So something like this. Okay. So after this, suppose I want to apply some condition. Having sum of this line total is greater than, suppose, some this value. Okay. So if your intention is like that, you can write this having clause and you can write that. Suppose you are not having this and I want to store this particular query result in a particular variable. Okay. So after that, I will apply some different expressions or different logic on top of this. So in that case, you can simply write this CTE, something like this, with some value, some variable name here. So it is something like product, yes, and bracket. with products as, and inside that you'll be having that, and then you can write select star from. Okay, so products is already a table, right? Select PR. No column is for column 2 of PR. City as. I don't think it is. This is correct. Okay. Yeah, yeah. Actually, this one, right? We need to give alias name. Sum of total. Assume that sum of total. Okay. So it is simply you are writing this in a particular query, and you are just using with city as. That's all. You can write whatever you want over here. So now this variable, whatever you are using here, this will become as a kind of temporary table. So the way you are writing the logic on your table, right? So same way you can write whatever you want on this particular table. Suppose the self start from table where sum underscore total is greater than 1500. Okay, so you should not use having over here, but because here sum underscore total is a column in your CTE variable CTE table. Okay, so that's where I'll be using where sum underscore total is greater than 1500, and suppose product ID in 717 comma 784. So both conditions, if both conditions are satisfied, then only those records will come into picture. So likewise, you can store your SQL output in a temporary table, and then you can be able to work on it. Okay, so that's how you can use this with city, and after that, whatever you want, you can do this. So this is very simple. That's all. Okay, so we'll see more examples with window functions. Okay. Um, Yeah, window functions will be discussed today. I'll come back to this CTE that time. So with that, what are the advantages of CTE? This is readability and reusability. Readability, it is cleaner than nested subqueries. Suppose you have lots of expressions and lot of inner queries you are using. So in that case, the readability will be maintenance will be very tough when you are using nested subqueries, correlated subqueries, something like that. So instead of that, just create something like this. So with CDE as this one, and then again you can have one more. You can have one more with CTE with something CTE one as, and you can write something else. And similarly, you can have one more CTE. So likewise, you can create multiple carbon table expressions, and finally you can write whatever you want. Okay, so that is how you can use this. Readability is very high when compared to subqueries and all, and reusability. Suppose you want to use this same logic multiple times. Okay, not this one, maybe based on use case. So if you want to use multiple times the same thing, you no need to write the same query multiple times. Okay, so you can just write this into this particular common table expression, and you can use that multiple times wherever you want based on your requirement. Okay, so that's how the performance wise it will improve the performance, and as well as reusability will be there when you are doing that. Okay, and avoid temporary tables. So before this, right, there is a concept called temporary table. So you can create or replace temp table, and you'll be creating some temporary table, and whatever the data you want, right, you will store that into the temporary tables. Okay, so that what is the disadvantage of for temporary tables? It will consume physical space. So it will occupy some data in your database, and whenever you want to you are done with that temporary table. So then you have to drop that particular table to free the space and for maintenance. So all these things will not be there when you are using this common table expression, or because scope scope is just to your subquery. Suppose you are done with this particular query. So after that, it will not available for any of the other queries or any in other things, right? So you can't use over here. But when you use temporary table, you can do that. Okay. So that is how since the scope is only at a query level, automatically that will be capturing the data, and whenever your query is done, automatically that free the space and no maintenance from our end. Okay. And scope to a single query. So that scope is to just a single query. Okay. So any questions for me so far? Okay. Um, and maybe one more example we can discuss over here. Something like so here we have. Okay, not now. Maybe during Windows functions only, I'll discuss that as well. Yeah. Um, and then we can go to case when statement. Suppose case when statement. When we use this case when statement. Suppose I'm using this product ID. So from this particular table, I'm extracting all the data from that particular table. Along with that, I want to add one more variable. So one more variable I want to use, so that I can maybe I'll use the same. Okay, I want to use one more column. So that column is something like the organization name. So my organization name is something assume avenue. Avenue is my organization name. Okay, and I'm making it alias name as org. Okay, so when I do this, apart from all your data, you'll be getting one more column, that is your organization name. So sometimes, right, you will be getting your current timestamp. So date time stamp or what? Get date. So when So when you are receiving the data and while inserting your data into your database system, sometimes we are expecting what is the current date along with your each record. So that time you can add simply this kind of logic and you can get that. Okay. So this is how you will receive, or you can be able to create one more column along with your data. Okay, so here, if you see, we are hard coding for each and every record. Okay, for my use case, based on some data over here, I want to make, I want to derive the column. Okay, suppose um, we'll take some simple example and then we'll see another example. Suppose order quantity, I'm having 1, 4, 2, 6 likewise. Okay. So if the order quantity for a particular product, if it is 1, I need to make that type is a column, and type I need to maintain as a single. If it is between if it is more than 1, I assume if it is more than 1, I can say multi. Okay. If your scenario is just like that, maybe what I can do is I can say comma, and I'm writing in new line case when order quantity order QTY equals to 1. When order quantity equal to 1, then I can say single. Okay. Again, you need to say when order QTY is greater than 1, then multi. Yeah, maybe greater than 1 and that's not equal to 5, then multi. Maybe I'll say hues. That's type of purchase. Okay, so I'm writing something like this. So here, the case statement, the way the syntax will be something like case when, and then these are keywords, right? So when order quantity, this particular column is some condition, then get this value. If it is not satisfied, then go to the next condition. When this is the condition, then get this value. Yes, this is the default value. So no condition is satisfying, then this will be your default value. And for this entire transaction, I'm giving a column name as type of purchase. So that's how you can rename, provide the column name as with as keyword. Okay. So that is how you can create. I'm not sure why it is coming like this. Incorrect syntax near the keyword as. Oh, end. Yeah, yeah. Okay, so you have to provide this end. So that means where this case statement is end. So that you have to provide. Okay. So if you go here, you can get single, multi. If it is more than 5, so there is no more than 5 entries. Okay. So here it is. It should be huge. Okay. Something like that. You can get the data based on some column values you can derive, and you can have that. Okay, so if you are aware of these CTEs or subqueries, case statements, so well and good. Otherwise, please practice it. Why? Because it's the same kind of logic you can see in PySpark as well. So case statements will be there. CTEs will not be there, but the concept will be there. Okay, so please see that. Okay, and suppose sometimes you based on the condition. So here, if you see, we are giving some hard-coded value. So instead of that, I want to give some other. So if it is something, I want to get this value. If it is something else, I want to get some other column. So if it is if your expression, if your use case is like that, you can be able to write that as well. Suppose instead of hard-coded value, maybe if I say, so any other column. Maybe I'll give this row GUID. Row GUID. So if this is the condition, I'll get the other column value to my derived column. So this is Why is this not coming? Okay, so this is different. Um, it should be the same data type. So that row GUID, right? That is different data type. We need some string. I think all these are decimals. Okay, so I'll do one thing. I'll say if order quantity equal to 100, if it is this one, then I would like to say product ID. All these are just manipulations. Okay, don't think like it is we are writing some logic. Okay, so just to explain you, we can use some column here. I just modified this to integer. So if you see here, if it is something, if it is one, you are getting this. Otherwise, you are getting product ID value over here. Okay. So likewise, you can use other columns as well while deriving the data, while deriving a column from the existing data that you can very well use by using this case when statement. So the syntax is something like this again, when some condition, then value. This is the default value. And you have to make end for that particular case statement. And you need to give this alias name to that so that you can create a new column with deriving the the data from existing column values. Okay, so that is how we will be using this case when statement. Any questions here? Okay. And yesterday we have discussed null, right? So null is something, it's undefined. So there is no definition for your null value. So the columns which are having null values, that means it's not a blank value. It's not spaces. Okay, it's not spaces or it's not a blank value, nothing. So it is just undefined. Suppose in a particular table you have a column 1 which is having null. In table 2 you have another column which is having null. Suppose in the similar lines I have table 1, some column customer ID, or yeah, customer ID is having 100. In table 2, you're having customer ID same 100. So if you join these two, obviously we know this 100 customer ID will be the output to your join condition. But when you have table 1 is having null and table 2 is having null, and when you join these, so since it is 100 and 100, I got output. Why? Because both are same. So similarly, when you join these two, don't think that you will get this null as output. Why? Because the null is not equal to null. It's undefined. So that is the reason you will not get null as output. Okay, so that kind of understanding you just get it when you use null. So sometimes I don't want to maintain null in my data. I want to replace that null with some other value. Okay, so I want to replace that with some other value. So that we can do by using two functions, that is NVL and coalesce. Okay, there are two functions. So NVL is something like, suppose you are receiving nulls in some column. In this table, we do not have any nulls. Hmm. So you have this null value over here. Suppose what is this? Credit card approval code. So that is having nulls over here. So I don't want to see those. nulls in my data. I want to replace that with something else. So then you will be using this NVL function, NVL of this one, comma, maybe it's a string column. I'll say something ABC. But NVL is not available or what? NVL is not a regular built-in function. Okay. So, so this is what I have written over here is portable and recommended. So NVL is not a portable function, which is available only particular SQLs. Like Oracle, we have NVL, but we don't have that NVL in multiple other. It's once again. Multiple other SQL tools, okay, technologies. So that's why we will be using this coalesce most of the times. It accepts only two arguments. One first argument is what is your column name, okay, which may have null values. If there is a null value, replace this with APC. Else, get the value from this particular column. It is simply equals to first underscore defined function of your ab initio. Okay. So similarly, we have one more function that is coalesce. Coalesce is a function which will take any number of arguments. Okay, so any number of arguments, and if it is null, it will replace this value. So it is, if I use just two arguments, it is exactly similar to your NVL function. Okay, so if I execute this, I can be able to see this value as ABC. So since we have used this, maybe we rename again to the required column. So this coalesce we will be using in PySpark as well. Okay. Okay. Likewise, suppose I want to use, suppose if it is null, I want to make some other column name, suppose ship method. So I want to use that. If it is null, then take the value from this particular column and get that value over here. If this is also null, then assign this value. So likewise, if it is null, then look for this particular column. If this is also null, then look for maybe some other column subtotal. Okay. If this is also null, then get the value from freight. So likewise, you can pass any number of arguments to this coalesce function. Whichever is the first non-null value, that will be assigned to this particular column. So that is coalesce function. Okay. So this may give you an error because I gave decimal values or something columns. Okay, so if you see here now, since it is null, right, I got this column value over here. So if any of these, suppose we'll see if we can be able to update some value. Update table, set ship method equal to null, where where 71796 sales order ID equals to 7796. Okay. So it is not allowing to have null into that particular column. This we'll discuss. Remember this error. Okay, cannot insert the value null. So this we call it as constraints. Okay. Let me tell you the constraints here itself. Yeah. So let me tell you the constraints here itself, and I'll come back to that. So whenever you're creating a table, suppose here you have created this particular table, right? So it's order header. So DBAs and data modelers, so they will decide that table structure, whether it is nullable, what are the different columns inside it, and what are the different nullable columns, not nullable columns. What do you mean by nullable? The columns which are defined as can be received as null. That means you can insert the null values into that particular column. So for some columns, it should not allow nulls. If it is some like here, you're using ship method, right? So shipment method, it should have something. So how you are shipping your good or product, right? So that should not have nulls. So that is the reason they have created a const so you can call it as. Okay. So similarly, you'll be having primary key constraint. So primary key constraint is something every table. So if you take product table, so product ID will be primary key. So that means inside your product table, no record will be having duplicates of this particular column. So if you go to suppose in a classroom, students, so student ID will be unique. So there is no two students will be having the same student ID. So likewise, suppose sales ID should be unique. So likewise, there should not be any duplicates and there should not be any null value. So primary key constraint, meaning there should not be any duplicates and there should not be any null value populated to the your column. So that is called primary key constraint. So likewise, you will be having foreign key. So foreign key constant is something. So if you see here, uh, product. So inside the product, the keys is something like, this is confusing. If you see here, product ID is the primary key. And similarly, if you see sales order detail here, the sales order ID will be primary key. And what sales is happened, like what kind of sale happened to a particular customer. So that will be on a product, right? So this product sold to this particular person, something like that. So if that is the case, so product ID will become as a foreign key in your sales order detail. So that means the product table and sales order detail table are related with the primary key and foreign key relationship using product ID. So product ID is a primary key over here because no records are duplicated inside the product table, but inside the sales order detail, there will be duplicates. There are chances of why, because same product may be sold to different customers, right? So that is the reason you may have duplicates inside your child table, that is so sales order detail. So you can call it as a master and child or parent and child, so something like that. Okay. So that is how this foreign key relationship. So this you can call a referential integrity as well. So some guys, they'll call this as a referential integrity as well. So whenever your tables are have relation with the primary key and foreign key, so that we can call it as referential integrity is missing. So that means that primary key foreign key relationship is missing. Okay, and when you're doing this, right? So what you need to remember is um, without having a record in your parent table. Okay, you can't insert a record into child table. Suppose in our case, right? So there is a product called something tennis racket. Okay, so one guy he purchased this particular tennis racket, and this has to be entered into this sales order detail. So they gave what is the sales order ID and sales order detail ID, and then order quantity. He has purchased two rackets. something like that. And then he has to give product ID. Suppose product ID he gave as 100 or 1000. But this is okay, but this entry is missing in your product table. So they have not entered into your product table for this particular tennis racket. So in that case, you cannot insert the data into your child table. So this will throw you an error saying the record is missing in your parent table. So when you are having this primary key foreign key relationship between the tables, we have to make sure on this part. So it should be there, but sometimes in very rare scenarios, you may have that issues. You just need to understand what could be the issue there. Okay. Then you'll be having unique constraint. Unique constraint meaning there will be some columns. Again, there is a slight difference between primary key and unique key. So unique key, I don't want to repeat. I don't want to have duplicates again on a particular column. Okay. So for unique grade, it will allow one null value. So for any one record, you can have one null value in that particular unique constraint column. Okay, so primary key, right? It is useful for duplicates, and as well as it is not allowing nulls, and as well as it should be useful for differential integrity. Unique is something, sometimes I don't want to repeat any other unique values into that, but it will allow only one null value. Okay, so in those cases, we will be creating this unique constraint. And another constraint is check constraint. Check constraint is something, suppose you are suppose take this class school. Okay, so you have a column name called subject. Okay, so inside the subject, whenever you are inserting into a particular table, student table or school table, there is a column called subject. In this, I'm expecting only maths, physics, and chemistry. Only these three subjects are valid subjects. So other than that, if you enter anything else, if I say AI, so that is an invalid value for that particular column subject. Okay, so if that is the case, while creating your table itself, they'll be creating this constraint, check constraint, which will allow only these three columns. Okay, so how do they create? Maybe give me create statement for check constraint, which accepts only three subjects: maths, physics, chemistry, into a table called subjects. Okay, so if you see create table subjects, subject name, not null, and constraint. This is the constraint name. So if you see, maybe I'm not sure if we have here, you'll be having, yeah, constraints. So if you see here, constraints will be here. So what is your constraint name? So this is the constraint name. So whenever you create, automatically those constraint names will be passed over here. So constraint name, check. What is the check? What is the check constraint? The subject name should be only in these three values. If something other than this you are passing, automatically your statement will be failed, just like this. So here it is null value, null constraint error, right? So similarly, you will get check constraint error over here. So these are the different constraints which we will be creating on the table. So who will be creating? Again, we are not the responsible persons to this. So this will be created by your data modelers and the database architects or administrators. They'll be deciding and they'll be creating all this part. But we need to understand, as part of your data engineering, right, while creating or while inserting the data into your tables, if you get such kind of errors, you need to understand what kind of constraints is defined and how to avoid that. Maybe if this is the case, how to handle these exceptions in your ETL. So in your data engineering, how to handle these exceptions. So these exceptions you have to handle in your PySpark code or ETL code, wherever you are using, right? So you should not get these kind of records until this table insertion. So you need to drop those records or you need to manipulate those records based on business use case and business transformation rules, you need to change that and you need to load that into your table. Okay. So this is about constraints. Any questions? Okay. Yeah, maybe this is how we'll be using Quailis. So I just came back to slide again. So Quailis, it accepts multiple arguments and it is portable and recommended. So as I mentioned, NVL is a limited usage into limited technologies, but Quailis is available in all the technologies. So the same logic we'll be using in PySpark as well. Okay. So the concept is same. Here you have NVL. So in PySpark, we'll be having fill NA. So fill NA is a function which will be using over there. Okay. Fill NA. And other thing is it evaluates, it accepts only two arguments. It accepts multiple arguments. And in NVL, when you are using arguments, right? Two arguments, it always evaluates both arguments. So if you write some logic, something like this, if you write NVL of suppose column name, comma, something date functions, or again, I'm using some NVL function over here. So you are writing some complex logic over here. So whenever you are using NVL, right, it evaluates this column and as well as this column. Okay, so whether this is nullable, null value or not null value, it evaluates, it executes this second argument as well, always. Okay, but Coilers, it's a lazily evaluate. So that means, so you are using columns like this, right? So suppose one more column one here, column two here, likewise. So whenever it sees, if it is not null value, automatically that will be populated to your column. If it is null, then look for this particular column. If it is not null, then assign this to here. Stop evaluating this other set of columns. Okay, so likewise, whenever your first non-null value comes into picture, automatically that stops there. Okay, that is how your coalesce function executes the functionality of your coalesce function. So this lazily evaluation, again, we'll see at the time of Spark framework. Okay, so the same word you can see there. So that's how this coalesce function works. So we'll be using all this very frequently as part of our projects. Any questions for me so far? Okay. Then I'll go to window functions. So before window functions, suppose I have some duplicates and I want to remove the duplicates. Suppose duplicated data, in which table we may have duplicated data. Product sales. Since it's already everything is primary key derived, we can't insert duplicate data as well. Instead of complete row level duplicate, I'm just taking sale order ID, revision number, status, status. Status. Ship method. Okay, so here if you see, I'm using what is the aggregate function, and I'm not using group by. So then you'll get this kind of error. So since you are using aggregate function, but you're not using uh, group by class, group by customer ID. Very good. No duplicates. Okay. Shall we create a table? Okay, I'll create one table. Maybe first I'll create a schema. Um, Practice, create schema practice. Okay, then I'll create this table inside practice schema successfully. Then I will see whether this is created or not. So let's start from honor card. Oh, it's not copied completely. So we have to give our schema name. Guidance near dot practice dot employees. Okay. Yeah, it got inserted. Maybe if you see here, so let's start from practice dot employees. So I have some data over here. Suppose I want to now I can say department common salary to department salary. So I have different data over here. And if you see here, I have 45,000 over here and as well as here. Okay. So I don't want to get duplicated data in my output. So in that case, we can simply go and do this distinct, and it will give you distinct records. So there's no duplicated data, whatever you are looking at your output. Okay. So you can be able to do that using distinct statement. But we can do the same thing using window functions as well. So we'll see that what is that window functions and how we use that. So to use window functions, basically we will be having three keywords. Okay. Uh, so it's 9:41. Maybe I'll take 10 or 15 minutes more today. Okay. Any issues? If at least ఒక్కరికి ఇబ్బంది ఉన్నా కానీ I'll not continue. Otherwise, I'll take 10 or 15 minutes more time today. Because we'll finish SQL as early as possible. ఎవరికైనా ప్రాబ్లం ఉందా?
No issues.
No problem.
Okay, thank you. Yeah. So to use this window functions, right, we will be having three important things. Over, partition by, order by. So these three we will be using while we work on this window functions. Okay. So here over is definitely we will be using this over class and as well as order by. But partition by, it is kind of optional. If you want, you can use it. Otherwise, we will not be using this partition by class. Okay. Um, so this window functions we'll be using for ranking purposes. The three use cases for window functions are ranking, and we will be using some analytical functions we can use inside this, and aggregate functions. Aggregate functions also we will be using inside this window functions. Okay, so first we'll start with this ranking. Okay, so inside this ranking, basically, ranking is something like this. Suppose you have um, or row number over partition by order by. Okay. So if you see here, we have created this ranking as an extra column. And what we are doing here, we are using order by salary. So in your total table, it will order your salary. Maybe it is in ascending order. And if you want, you can make it as a descending order so that your highest salary will become first. So 1, 2, 3, 4, 5, something like this. So what I will do is I will say a row num. The column name, I'll make it as a row num. So this will order your data, and it will give you the ranking starting from 1 to maybe 100. Since we have created 100 rows, it will give you 1 to 100. Okay, so this is one function where we will be using for ranking. So which will give you only in sequence wise, it will give you the ranks. Okay, so other one more thing is we have rank and dense rank. So if you see here, I have 76,000, 76,000, 75,000, 75,000, 74 three times. So likewise, we have duplicated data. So even in that case, it is just giving you 1, 2, 3, 4. It just goes just by incrementing your sequence number just like that. So sometimes our intention is I don't want the ranking like this. If I have values, similar values, then I want to give the same rank to that particular part. So in that case, you can use that use this with a rank function. Yeah, if you see here, it gave the same values over here. And since it has two records with the same rank, the next value, it should become 5 because two values are gone here. So similarly, I have 7 7 7 three times. So after 7 three times, so the next value is 10. So likewise, you'll be getting when you use this rank. Okay, so the same value will be given, but the next value will be, you will be getting the next sequence, not the four. It should not go in the sequence order, but it will skip and it will go to the next value. So simply you can say when you use a rank, it will skip the sequence. Okay. So sometimes, suppose my intention is I want to get the fourth highest or fifth highest or 10th highest. Then you can't do that by using this rank. Then you need to use dense rank. So the same thing, dense rank. So dense rank, when I use this, you'll be getting your value 1, 2, 3, 3. So here it skips and it goes to fifth, but it will give you 4, 4, 5, 5, something like this. Okay. So these are the three functions which we will be using as part of this window functions and this rankings. Okay. So if this is the case, I want to get one very common examples. Please don't mind. Actually, I'm not well, so I'm getting frequent coughs. So I want to get the highest, maybe fourth highest salaried employee, or it's not only salary, why? Because many of the videos, many of the tutors who are explaining, right? They even me, right? So they'll take the example of this employee salary. Okay, but don't stick to your analysis only to that particular table. Okay, assume that this is sales table. So which is the fourth highest region in sales. Okay, who is the top five customers for a product? Okay, so likewise, if you say something like this, who is the top five or 10th highest, or who is the least customer who is spending money with us. Okay, so if you have such kind of scenarios, then immediately you can think of any one of these functions. Okay, so don't stick to your learning only to that. So in with these things, right, you can be able to get it very easily. Suppose I want to get the yeah, I'll say I'll use this inside a CTE entire thing, and I'll say select star from CTE where maybe this dense rank equals to 5. So this will give you who is the fifth highest salary employee. Maybe who are the top 10 employees. So simply you can say less than 10. So this will give you the top 10. Okay. So likewise, you can manipulate. This is how you can use your CTE. Very simple, right? So simply you are storing into this particular table and simply you are using that over here. So simple. Okay. So this is how we will be using these three functions. Any questions so far? Okay. So now what we have done, we have taken these ranks, everything at employee table level. So the total employee table level, we have taken this. But I want to see the ranking within a particular table, sorry, within a particular department. So if you want to do that, so simply instead of over, you can say partition by. Partition by department. I mean, equal this. What happened? Partition by department. Okay, partition by department. So if you see here now, oh, everything is in, okay, yeah, finance. So if you see finance 1 to 18. So similarly for this guy, since this is duplicated, we got 17. And for this guy, we got something like this. Okay, so since we have same values over here, something like that. Okay. Yeah, likewise, you can group based on a particular column and then get these values. So similarly, a very common question in interviews especially. So these are the common questions basically. The highest, this highest, lowest, something like that. So how to delete duplicates? Okay, how to delete duplicates for your data. So if that is the case, you can simply use this with CTE, and you can say here delete from. Suppose you have duplicates over here. How to say that? Yeah, inside this finance, right, I don't want these many records. So I want only one record on this. So in that case, you can simply go and use this one, this one, and I can say greater than one. Okay, so simply it will delete all the rest of the records and maintain only one record on that particular group. So whatever the group you are using. Okay, so likewise, you can make use of this window functions. So window functions very common in SQL, and as well as PySpark also will be using very frequently, very common scenarios will be using inside PySpark as well. Okay, so remember that the concept is same. Okay, any questions for me so far? So when you say department, or when I say something else, maybe if you take product, maybe product category or product. So on suppose on date level, something like that. So if you are doing something like this, what do you mean by this? This is called granularity. So if you remember, if you are aware of it, okay. Granularity is something what level of information you are using, what level of aggregations you are doing. So that is called granularity. Sometimes, right? Get me the list of sales or revenue or profits on a particular day on daily basis. Okay, sometimes on weekly basis and sometimes on monthly basis. So what do you mean by this? Daily is the granular level where you are looking at, or weekly level or monthly level. So what on what level you are grouping, so that decides your granularity. So remember that. Okay. Uh, yeah, that is another part. So any questions for me? Maybe I'll stop here for today, and tomorrow I'll continue with this analytical functions, aggregate functions, and then correlative subquery is a small topic. Constraints we have discussed. Yeah, maybe I'll try to finish by tomorrow this SQL, and then we'll start with Python. Okay, so if no questions, I'll stop here. Okay, then. Thank